Hey everyone, welcome to the episode of Agentic Workflow series. So, in this series, you're going to witness how to build an agent and what all tools that we can include, how to include design pattern evaluations, and how to integrate with MCP and orchestrate using LangGraph. So, end of the session, you will be able to create a complete agentic workflow by your own. So it is user friendly, beginner friendly. Anybody who wanted to start or intermediate people can follow this. So don't skip any episode that I'm going to upload in upcoming weeks. So let's get started with a basic agent. So here I'm just having a calculator. Don't think that I'm going to have only the calculator tool in here. We're going to have like multiple tools integrated. But to start with, I'm just using calculator in order to make you all understand easily how it works. So agent is nothing but a representative or someone who's going to do your job instead of making them to understand each and every terms. It can do by thinking on its own, something which we can term as autonomous. So I'm using Gemini in here, and model is Gemini 2.5 Pro. And what you can see here is a calculator tool where we just gave an instruction for the tool in here. So what it does is evaluation. So it does the evaluation based on the expressions that we are giving. So this is what the function for calculator, I mean the role for calculator. We didn't include any of anything in it. We just gave an expression like what calculator does and how it need to perform. That's all, like with the evaluation function in here. Next, what we have is a model name, and we're just going to start with a simple chat, a starting chat that we can invoke with a question, I mean from the user. So this is what it does. So response can be made with the help of chat, which invoked using questions. So for example, the chat dot send message question. The question is, what is 14 times of 47? That is what our question. Like you can change your questions, anything. We'll see. Next is the model need to be respond back. So we already have a tool called calculator. So it directly goes to calculator and get an answer. It didn't send a message to Gemini directly, but the Gemini will act as your agent in here. So LLM will bring what user ask, anything it may be. So it does not know what is 14 times of 47. Instead, it uses calculator and waits for calculator to respond back. So that is what Gemini wants to use the calculator to. So this is the first part of function call, that is our tool calculator. Next, what the expression which is about multiplication. So based on the expression, it calculates and gives to Gemini, and at last we'll have the answer. So calculator results will have results in here. So calculator math expression, which we gave it as a first part, which is the function call happened in here, the calculator and the expression. So get the math expression Gemini wants to calculate. So Gemini does not know what is the expression meaning and how to multiply and all. Gemini is a mediator here. That is your agent. And calculator is your tool. I hope you understand these two difference. Gemini, I mean LLM can actually do the math, but instead of like getting into hallucinated one, we can ask or bring or include any tool directly so that it won't make any mistakes, any sort of mistakes. So a simple calculator tool instructs Gemini what to answer, what to reply. To frame the sentence for users as a response, we are using Gemini, and this function is going to do that. So after getting the results, we are getting that from the calculator and invoke that into Gen AI. That response happens after that. So let's run and see how it is actually doing. So user asks this question. So Gemini wants to use a calculator. Expression have been made, which is multiplication, and we have an answer. So if we go and give like what is 23 times of. So not only this, it understands what it actually expression is, and it gives the exact answer of it. Now, so it understands what is divided by the particular expression is. So the sentence have been framed using Gemini. So Gemini's final answer 123 divided by 47 is approximately 2.617. So the intelligence have been made, but with the fact that we have given as a tool. So this is what an agent actually does. Instead of like directly feeding everything into LLM, we can use tools in order to reduce the hallucination or misleading information. So maybe in next session, we'll see more about this full functioning of an entire agentic workflow as a first step. So I hope this agentic basic you would have been understood, and try to create on your own like using different tools. Anyway, I'm going to do that in my next video. So we're going to have a single agent with multiple tools. So before that, we'll see like the simple roadmap for this agentic workflow. What all we going to have? The first three things that we previously saw, the basics. But here we're going to see something like a little more on that, so that for we can have a better understanding on that. So foundation is nothing but you're going to have LLMs. Without LLMs, we cannot just work with agents because it cannot think without LLM. So the limitations that we talk about LLMs is it does not have any memory. So when you ask, it tells you what to do or gives you the answer back, but it won't have any memory of what we asked previously. So we need a record of that. Without that, LLM does not have. It knows, I mean, it answers what it knows, that's all. So the core agent loop should have like, it should observe and think and act. Then it sees the results and repeat the entire process again. So it should have a continuous process of understanding what the situation is, and it should act based on that. So with LLM, we can do such thing in the form of agent. That is what we call as an agent, where we give or assign role to each other, to each agent that we, specify or create. So what is the difference between chatbot and agent is? Agent is act based on your goal that we specify. But when we ask chatbot, when we work with chatbot, you ask something and gives you back the answer if it knows. So that is the different. We can, customize, chatbot. That is called your agent. You can, if the agent or chatbot, customizing it, when we customize it, that is called as agent. So that is the difference in here. So, and also agent will act based on the situation, as I said previously. So it think if nothing is working out, it won't give back the answer saying that it is not working. It will actually ask by itself like why, and it search for alternatives or other things for it. So this is the foundations. If you know this, this is the basic. Understand this. What is chatbot and agent? Why we need agent? So it compare prices, picks the best. So it literally can think because we are giving the ability to do it. Next is we're going to do with a tool. First thing is tool is not agent. If you are going with mobile phones, applications are your tools. So we can use multiple applications, but operating systems is your LLMs. So with that, it performs all the tasks. And but here LLM says like which tool that I need to use for specific task. So tools are something which would be an add-ons in order to reduce a hallucination or to have a correct or exact results and to make the LLM process easier. And it would be like a structured way of having the entire model. So the simple tool definition in terms of LLM we can give is like name, description, and parameters. Like what is the name of the tool, which may example like weather or web search or anything it may be. Here the description which we are giving is get current weather for a city. And description, I mean parameters it should have like which place it should have, right? And units like it may be in a string format that I need, and the units, what units in the format of what units that we need to get the weather update, Celsius or Fahrenheit. So these are the simple definition that we can specify tool to LLM, so that LLM will understand what is this and for what I can use this for. So would description matter most? Yes. When we describe about something, we cannot just specifically say that this is what it is. We should be like explaining clearly about it, because it is machine and it should be able to decide why I need to use it. So in that way, you should give a specific description, like bad description or a name. We can give a search. What search? Whether it is a document or web search or what it is. So for that, we are giving search company documents, description, search internal company documents. We are not saying like go and search open source. We just specifically give, or we can give a particular website or source that it need to search in. And handling tools error, we can say that call both at the same time, or it need to search specifically like do this first, second do this, like search for hotels and then book, which is the cheapest one. So we can give in this way, instead of like going and facing a failure at a certain call that nothing is available kind of results. So we can avoid such thing. And the next thing is prompting agents. So prompts, we have like system prompts where we need to specifically assign roles. Anyway, we're going to see it in agent calls. For agent or to call a tool or to decide which tool to be used, we need to give a system prompts properly. Or we need to give like properly like rules or examples and what way it need to use the particular tool or actions it need to take. So everything we need to explain properly. Let's say like one example thought, the user wants to know their order status. I need the order ID first. So action ask user for order ID. So that was the first thing that it need to do. So likewise, we are like structuring the Q&A for agent to ask to a user. Then the conversation would be with clarity, and it will be like with the quality also. So let's see like a complete example for this in code so that we can have a clear understanding. So in previous session, we saw AI agent, right? Like single agent, which would be using a single tool. But here we are having like multiple tools, how multiple tool call can happen. So that is what we're going to see in this video. So as we saw the three phases of agentic workflow, these are the basic for those three fundamentals to start agentic workflow. So we can go with any LLM model. I'm using Gemini again, and I'm using calculator, web search, and unit convert. So these are the three tools I'm using. And I just gave the functions for each, what calculator would be doing, which is evaluations based on the expressions. And web search, it can search on particular topic or query that have been made online, that I've just given. And unit converter, I just gave directly like what it need to do, like kilometer, miles, kilometer. That conversion I just gave as basic for LLM to understand like what it need to know. So these are the tools and its description. And next we are going with system prompt. So in system prompt, I just gave like 4 rules. One is use tools for the specific task. Don't just randomly pick tools. If LLM knows the answer, you can actually answer it directly instead of searching tools. If the tool is giving wrong answers, be cautious, understanding like whether it is right or wrong, which means it has a evaluation. So I also included that. And ask user to give correct questions, and just keep missing information. Ask the user to specifically ask proper questions like convert 10, what it is, nothing. So it should clarify them with them instead of thinking directly and bringing that to tools. So these are rules that I have given to LLM. So I just wrote it down as a system prompt. Now, so in last session we saw we used Gen AI Protos, which is a structured way of giving function calls to Gemini. So whatever the results that we are getting from tools, we need to give that to LLM to respond back to the user. So we are using Gen AI Protos, which is nothing but a simple way of similar to JSON format that we write, right? Like structured way of writing, like objects. Similar to that, we are giving a language to LLM to understand like what parts it is, and content, part, and function response, name and response. So it is like structured for every like tokens we split, right? Something similar to that. So we are bringing the results from calculator and sending the results to LLM. LLM does not know what is calculator, what it does or not. It just takes the results and gives back to the user. This is what I got for your question. So same thing. I'm just using a simpler version of agentic call function response here. So anyway, I'm using Gemini in here again. The next thing is, I think I should change the model. I've used 0.5 Pro, same thing. So here I have configuration. So we have content in here and calling system prompt and tools, 3 tools specifically, and automatic function call. Function call is LLM will decide which tool to be called. And later the content, I mean the response is added into the conversation, and LLM again will process the answer based on the rules, I mean the system prompt that I have given, right? Based on that, it will process the results and gives back to the user. This is what the agent will do. I'm using single agent, but 3 different tools in here. So it is, all the functions which is here is very simple, and it is easily available in Google Doc. You can refer to that, and you can try to write on your own few things. Simple things. Next, we'll try to run this and see. So these are 5 questions I have. This should be responded in a expected way, because it is not a clear question. And this should LLM can think and answer. Anyway, we have web search and it should perform without even considering it. Let's see. Okay, it started giving me answers for it. First thing we have is uh, final step. Okay, so we got the answer for first thing, like 23 times of 47, and convert 10 kilometer to miles. Yes, and what capital Australia? Canberra, and final answer ready. So this part here use convert 50 miles to kilometer and then multiply that number by 2. So these things it does, and without even hesitant to search and ask in a tool. So Gemini wants to use one tool. So here I've just asked it to mention if it is using tools, it will say like it is using two. But here it didn't use a tool. It just know the answer, so it answered directly. Next, the final answer is ready. What unit do you want? So it just asked again the user that what is the question, clear question. And here it used a calculator, here it used a converter, and here, yes, again the converter. So here the web search have been made by LLM knowledge. It didn't search for it. So specifically, I just gave on that web search. So if it knows, it will answer. If it didn't, it will search or ask us to approve or something if we specify on that part. So yeah, I forgot to increase the size of this thing. Don't worry about it. I'll share the code anyway. End of this session maybe, or I mean end of the session in the sense entire this series. We can have the entire scripts ready. But yeah, make use of this. Try to create one for your own so that you will have better understanding. Leave your comments if you need to know anything about it. In previous session, we saw multiple tools connected with an agent. So agent will call a tool based on the query have been asked from a user. So for a math calculation, it will call a calculator. But how it is actually handling the entire list of tools is we just append every tool list, and we have mentioned that in the tools. So calculator, web search, and unit converter. So it calls based on that. And also we have added an error handling for tool failure. So every time when a tool call have been failed, it will send or instruct a model that a tool call have been failed. So the results have been made by the LLM. Now we are into this decision making by an agent. The same tools that we are handling, I mean calculator, unit converter, and web search. But the decision made by agent is through this call. So we are just including a decision function where if it is math, the decision have been made to a calculator. And if it is any search, then it depends on the web search. So that decision have been, instructions have been given to an agent and through this particular prompt. So LLM will be deciding this, whether the query is math or search or any conversion is happening inside. So that have been done. So let's see how it is working. So it has have been sent to root agent, and router is actually thinking and deciding which need to be called based on the query. So it is deciding who should handle this. So the decision is making through LLM. That is why I'm giving the model name. I mean model. So router agent decides who should handle this. So this is what here we are saying, and based on the questions, it decides which to be handled. So this respond text dot strip actually does the similar to regex decoding, and the decision takes the message to L, and based on that, it is getting the answers. I mean, it is giving back the answers based on the tools that it have been decided and used. So in this video, we're just going to see a complete multi-agent system with a core of these topics that we have seen in previous episodes. So I have included memory and state and planning mode for agent and multi-agent system orchestrated using LangChain or LangGraph, which would be using a RAG a model inside. So what memory and state does is it remembers every state of information that agent and the user have conversated, and also the retrieval and response which would be stored, so that at any point of time the user comes back and asks the agent, it responds with the updated information that it have in a memory. So planning is made by agents by certain research tools that have included, and whatever it is going to do as an agent, which user asks do. So whenever it decides on certain things, I have also included an human approval form where it gets back to user whenever it needs an approval to proceed with the task that we asked it to do. So that is the planning mode. And when it comes to multi-agent, as I said before, it is going to orchestrated using LangGraph or LangChain. And retrieval augmented generation is the one which is going to use the vector DB, because we are handling memory and state in here, and also human conversation is actually happening. So it need to understand in terms of agent in order to process. So let's see how these code is happening in between. If you didn't or not understanding any of the part about agents or handling multi-agents, refer my previous episodes so that you will get an idea of. Okay, first we are starting with agents. So for that, again, I'm using Gemini as to have a flow. So here we have a function called call Gemini. So the model would be called whenever the agent is pushed into a task. And we have a planner agent. The task is to make plans for every task that is given to it. So it just assign plan like what it need to do and what all things that it need to refer, where to call, and who to get approval with. So it plans every user instruction, and it manages the session ID also. So I've given in order to handle the memory. And we have agent 2, which is research agent. This agent will research on topics which have been given to it. So any tool that it need to be used, we have given tools also. I'll explain that. So research agent job is to research. That's all on out of view. And it calls Gemini. So whenever we are giving it to a task that need to be managed, it understands through LLM. So LLM is a kind of a translator for them or a representative. So whenever they need or send results to user, whenever it have a user interface or a user conversation should happen, then LLM supposed to be there in order to bring back those information and agent to agent communication. So for the result sharing, we need LLM, and also for the user understanding, we need LLM. Like a communicator, someone who's in between, a mediator kind of, that's LLM. Without LLM, agent cannot communicate within or outside. Next, we have a write agent. Writer agent will work together with research agent. Whenever he shares information to it, it starts writing. Before that, it need a approval or feedback from user. So that is also there, been included. So reviewer is a one. Whenever the write agent asks whether I'm going in a right direction, it approves, it instructs, and that approval have been given by a user sometimes, and LLM would get back those information. So this is how it is happening in backend as an agent. Now we'll move to in terms of tools. We have a web search. So it is application where we're going to have a blog. We're going to write or automate writing a blog about AI or ML. So that is our use case. So as per that, we have those agents. And for that, we need this particular tool called web search. So it searches online and does call the agents allocated for every task at it. So we have a given like source of information, which is vector DB. Why vector DB is because it need to know what all it have been written so far. Whenever the user comes in after like so many approvals and rejections, it should get back to the last approved information or last rejected information, so that it won't repeat the mistakes again. And if even after a few days or any time they are coming back, it should know where they actually stopped. For that, we just given the information of vector DB, and we'll go into this memory storage before getting to the yeah. So we have memory, which I'm including a chroma, and we need embeddings for that, because we need to convert text into numerical format so that machine can understand. That's how LLM understands and takes to the agents. And the memory state we are managing, so that we something like session ID or anything that we can say, so that we don't lose any track of it. So we are having a state and events for it. So for that, we are using LangChain that we will see. But for memory state, we are just pulling those information for it. So it's nothing but a user memory, and also machine memory is also handled in here, which is in here. So memory type that I'm giving. So topic wise, it will be added in using memory ID. So this is user memory. The user, whenever the user asks, that also would be stored. So entire conversation you will have, and search relevant memory. So we just assigned for each task a memory, like a title we have given, so that it is easy to refer for user as well as LLMs based on the ID. And we are going into this graph before going into communication part. So as I said, we are using LangGraph. LangChain, why we didn't have? Because it is a linear format of having orchestration, getting together. But when I go with LangGraph, it can handle multiple state, like you can have up and down. Any agent that you can continue working with, or in loops. Whenever there is a loop, we have agent call, and the event based and session ID have been managed very well with LangGraph compared to LangChain, because this is not a linear model. So we have human approval node in here. Every agent, the roots have been managed, and all the agents have been added in nodes with the help of Edge, the planner, researcher, writer. We have everything in here, and human approval. So we have all those, and this communication is happening all together with the help of MCP. As we see, this is a very complex system. if we are like getting into big picture, it involves like a lot of conversation back and forth between agents, between user and agents, and inside the model where it searches the web and gets back the result. If the information is already taken, it need to eliminate and research back with the help of reviewer. So all these things which would be taken and constructed with the help of MCP. Without model context protocol, it is hard to manage the state and LLM calls. So for that, we are using LLM. So we have like read and write. So whenever there is a data comes in, it just takes to the appropriate agent or tool. Likewise, we just gave the updated context. So any information that have been updated, like response, it may be yes or no, or approved or rejected. That updated information, which would be taken to a respective agent or a tool, or any conversation loop it is currently in. So that session ID have been managed. So every thing that is managed with a vector DB, and we are assigned with an ID, a specific ID for it. That is how this entire communication is happening. And I didn't write like much of a rule for it. It's a simple rule that you can understand. Data, where we are calling using session ID whenever there is a new update in it. Same goes with the context, like new context and a particular context that ends with a proper relevant messages that it is getting. So I'm just giving it as an field. So new field, new context, updated information, everything we have like called with a read and write operation. Yeah. So read and write operation have been given. So reads and it writes. Next. Yeah, we have seen this and graph. At last, we have main. Main is a calling function. I mean, the main function where we just operate this entire system, agent system in one go. So now let's see how it works. You can see the chroma DB have been created. So the planner agent have started. Since it's a demo video, I just asked it to make like 4 lines. So we can see the communication here. So plan has been made and memory used, research notes. How the MCP actually communicating, help the agent to communicate. So you can see it is getting updated. So finally it is asking me to approve I need to read this whether it is okay or not okay. Do I need to add anything? I can add. So this is how the entire model works. So verdict is waiting for my approval. Let me approve this. What if I say no? What should I change? So this is asking me. This will be it works too many. Uh, I- So this communication is happening with the help of LLM. So it is assigned version 1 now. So previously it was version 0 and yeah, we have it in bulletin. Okay. Now I'm approving this. So this verdict you're seeing is a reviewer agent, which is gave. So save to final blog post. So we have the blog in here, which was given, which I approved now. This was the bulletins in here. Yeah. Okay. So that's all I have for today. I just made this session in order to have like overall view how this agentic flow happens in terms of memory, and we have the orchestrated using LangGraph and this MCP communication. So it is a big picture, it is a huge model, but I just wanted to make it like very simple so that everybody who's like new can understand this. So now we want to see guardrails and safety and evaluation and debugging. So how to evaluate your entire multi-agent system or any agent that you build. These are the steps that you need to follow in order to have full functioning and error-free system. So guardrails are when you set limit for agents and human verification or approvals in between, and setting limits for loop in order to end the forever loops. So sometimes agent will stuck in forever loops. So infinite loops can happen if we are not setting the limits for loop. So that we need to do. This is guardrails and safety. And when we go with evaluation and debugging, every time that we do, we need to have log. So logs for everything, and so that we can have the repetitions tested or tool failure, and if any missing information, and if anything ignored in between that. And metrics to track is to have ask the user directly by giving whether the task have been completed or the satisfaction uh, inputs, whether the user is happy or not, and the tool accuracy that we need to check with a log file saying that whether a particular tool have been called every time. So user satisfaction is the utmost end goal. So when they have given like out of 5, 4 out of 5 and 9 out of 10, then the model is working fine. If it didn't, we need to go back and check where it is actually not working. So this will see how it is working in code. So guardrails is something where we just give the token tracker, the logs for everything. So we already have session ID and multiple progressive agent tool tracker. and we have record of everything. So this record function will collect all this information like prompt, completion, and total tokens are being used. And with that, we can just have a accuracy kind of calculation that we make with that. And record fallback, we just need to have how many have failed that record, and a summary of that for understanding whichever uh, agents or functions have failed, we can backtrack and rework on that. So total tokens. So these are like simple function where you just call and have it done. So you can see these are the rejects thing that we can consider and send that to LLM if possible, or we can track it direct string match. That is also a valid one. So we just given like all those terms like input prompt injection, blocking, injection pattern, and topics which will consider all this pattern. So we have given all those instructions to it in order to handle the blocked messages or agents. And if needed, you can have this PI deduction if in user text or response from LLM. These are like add-ons that I just included. And check content safety. This is another thing like violations or any hate comments, dangerous or misinformation, whether the agent is sharing too much information to users where they don't have to have those information. So we can restrict all that. So guardrails will include all of it, and you can include anything that is more needed and exclude some of the things which you don't have to have at the priority level. And the output format, this is, I mean, another one. So hallucination check is another thing which we still face issues with, and we just include in prompt that the agent need to check with the facts, like or the fact checking assistant have been included with a source or any web search that can be tracked with certain keywords in it which relevant to the user questions and the source that it has, the data source it has. So with that, we can give the hallucination free results. And also we are using RAG where we don't have to deal with hallucination much, because anyway it is going to retrieve with the source of information that we have given. So now we are just going to call every functions that we have given. So PII and content safety and output format in the not violating anything like hallucinated, not hallucinated results. So these are that we need to have. If you ask me, do you need guardrails? Anyway, we are making the agent perfect. No, we need it. At if you are like sending a full production, sending it for a production, you need this and evaluation metrics. So let's go with evaluation now. And here is the evaluation where we just assign like score for every agent, every results that we get. And from that, we can assign these are like above the threshold and considered as a good results. So likewise, we just set up with a score like -1 is poor, and we just have like accuracy, completeness, engagement. So these are like terms that user need to give us a feedback, and we just assign scores with. After that, we can calculate the score based on that. So yeah, and considering debugging logs, let's see like how it works before moving with the assumption. So if you ask me, is this running by rules? It is not. If you are looking at the results, it is directly fetching from the web. That was our tool that we included. In the beginning, it was saying that we have three warnings uh, from guardrails, and it have been blocked. And yeah, so guardrails, three warnings, and found non-blocking. So it just got approved just because it's a warning, and nothing was serious. If you see the quality score of this, we have like 6.8, which is above the threshold that we assigned. If it is like below 0.5 or 5, it would have given us a warning that we need to reconsider the topic, or we need to ask agents to search more and elaborate on the topic. So this is how it actually works. When it comes to hallucination, the React loop allows the agent to recover from the errors. So this was a hallucination warning. And you can see the JSON output for function call includes the parameter unit Celsius. So these were the identified hallucination, which was flagged. And you can modify based on the requirements and the needs. So that's all I have for today. And I hope you all enjoyed this entire series. I'll post everything in Git repo. You can clone and make use of it. Thanks for watching. Bye.